All right, in lesson 2.6, we're going to go over the derivatives of tangent, cotangent, secant, and cosecant. And by the way, I'm using the trig identity sine squared of x plus cosine squared of x equals 1. So there's a little typo in there, but we can take care of it right now. We also want to use the identities. Do you remember tangent is going to be sine of x over cosine of x, and secant is 1 over cosine of x. So hopefully those are at the top of your mind when you think about those functions. And when I want to do the derivative of tangent of x, since I don't really know anything about the derivative of tangent of x, it seems immediately obvious to me that I would go ahead and swap it into that definition of tangent. And so then let's take the derivative of that, because we already know what the derivative of sine is, and we already know what the derivative of cosine is. So that first step is something I just know isn't obvious until you've seen one of these. So you'll be seeing two of them today. We're going to do tangent and then we're going to do secant. So when I have sine of x over cosine of x, I'm thinking, oh yeah, that's going to be the quotient rule, right? And so I imagine myself saying, hey, I have sine in the numerator. I remember I have to take the derivative of that, so I'm going to get a cosine. I remember that if I have cosine in the denominator, that I'm going to have to take the derivative of that, and I'm going to get a negative sign. And I'm just organizing my thoughts with regards to the original function and its derivative. And so when I set up the quotient rule, I do it like this. I have something times something minus something times something, and it's all over something that has been squared, and that something is supposed to be the denominator. So the denominator is cosine of x, and I square that, and then on top I should have cosine of x as the very first thing. This is how I have the quotient rule memorized. And if now I say, usually I say, I come over here and I'll point some arrows. It's just a little bit confusing because they're all the same, but there you go. Cosine goes with cosine. So I will have a cosine here, and I will have a sine here, and I will have a negative sign as well. And so I immediately am saying to myself, well, I have cosine times cosine, which is cosine squared, and I have a sine times a sine, which is going to be a sine squared. And don't forget, the negative times the negative turns into a positive. And whoa, hey, isn't that our identity? Didn't we already learn that? Cosine squared x. And then I say, okay, yeah, we do know that. And since we know that that's equal to 1, we just discussed how I was going to use this identity. I'm going to go ahead and use it right here. And I'm going to say that this is really, ready, equal to 1 over cosine squared of x. And then I say, oh yeah, well, I also meant to use this guy right here. And so isn't this going to be equal to, well, 1 over cosine of x would be secant x. So 1 over cosine of x being squared should be secant squared. Okay, and that will be the derivative that I use from now on. And I believe we have it listed right here. The derivative of tangent is secant squared of x. So the derivative of secant goes in a similar fashion. Since I know that secant is 1 over cosine, let's go ahead and rewrite it. I want to take the derivative of 1 over cosine. Why do I want to do that? Because I actually know what the derivative of cosine is, and I can use it when I am doing the quotient rule. And again, if I think about the quotient rule, if I have a cosine of x and then I take the derivative of that, I'll get a negative sine of x. The numerator was a 1, so when I take the derivative of that, I'll get a 0. And so I'll say that the derivative of secant of x with that quotient rule is something times something minus something times something, and it's all over something that's squared, and those somethings in the denominator are supposed to be cosine of x, and the very first thing is also supposed to be cosine of x. And so I think about how the pieces lay out, and oh my goodness, that cosine is going to be multiplied by a 0, and this 1 is going to be multiplied by a negative sine of x. And so when I simplify that, if this is 0, negative times a negative turns into a positive, and 1 times sine of x is sine of x. So sine of x over a cosine of x that has been squared means that I have these two things right here. I have 1 over cosine of x, and I'm multiplying that by sine of x over cosine of x. And those are the two identities that we've already seen, right? I already said I was going to use this identity. There you go. Matches the yellow to the yellow. And here the orange matches to the orange. And so I now say that my derivative of secant is going to be, ready? It's going to be secant tangent. And you can see that guy right here. Now, when I lay out trig functions that I have memorized, I don't lay them out in this way. You know, sine going to cosine, tangent to cotangent, secant to cosecant. That's not the way that I have them memorized in my head. So when you see me do the freestyle, I'll be talking about it in a different order. But the derivatives are the same. Okay, so this format of how he's laying these out is not a bad format. Noticing that the derivative of cosine turns into a negative sine is kind of cool. Noticing that a secant squared turns into a negative cosecant squared. Noticing that the secant tangent has a corresponding cosecant, cotangent. And here, I think the reason why he's highlighting everything in this order is these ones are all negative. And notice how they all start with a C. So that's kind of handy. And so I think that's why he lays them out like this. And if you like this way of laying them out, when you do your copy 5 times, you obviously can copy them in this order. All right, but check out the freestyle to see how I do it, and then make your decision on which way you want to keep them memorized. From now on, these formulas can be used, making it unnecessary to use the quotient rule process for these simple functions. By far the most common errors in using them involve incorrect signs. Can you see a quick way to remember which derivatives needs negative signs? I'm hoping that you see that if it starts with a C, right? If the derivative that you want to take is of a trig function that starts with C, then it should have a negative sign in front of it. So the derivative of cosine should be negative, the derivative of cotangent should be negative, and the derivative of cosecant should be negative. All right, so I want to take these derivatives, and remember at this point that, you know, all these functions are just the basic function and the basic derivative. Whenever you see a number here right now, the only thing that's interesting about that number is that it's a multiplier, and it should still remain in your answer, right? Because when we multiply by something, then that's like a slope. So we want to keep that. So I'm going to say then that the derivative of cotangent from up here, the derivative of cotangent is negative cosecant and cosecant squared. And so I'm going to say that I should have a 4. It's going to be multiplied by negative cosecant squared x. And so what will my derivative be when I'm all said and done? It will be negative 4 cosecant squared of x. And think about this number. Anytime you see a number there, that number should also appear in front in the derivative. Number 2, however, is a little bit more tricky because I want to just take the derivative of tangent, and I got that. I know that's secant squared, but there is an e to the x in front, and that happens to be another function. So this is another example of the product rule. I have something times something. And so if I take the derivative of e to the x, I still get an e to the x, but when I take the derivative of tangent, I will get a secant squared. And it'll be this times this and this times this. So my derivative, y prime, will be something times something. So I'm going to say e to the x times what? Secant squared x. And it will be an e to the x times a tangent x. And I really don't need to do much more to it. So for number 3, I really feel like I don't have enough room here, so I'm just going to snag it. Give myself a little bit of space. All All right, so I've got the quotient rule, and I know I have a cosecant of t, and I'm looking at the derivative over there. I remember that it was going to be cosecant of t, a cotangent of t, and don't forget that that's a negative. And then I have a t squared, and the derivative of that should be a 2t, right? All right, so when I set up my derivative, f prime of t, I just want you to know I'm not in love with the t's. I'm not great at writing t's, so I try to write a t like this or like that, and I can't really ever tell which one I'm going to do until I do it. So it doesn't bother me that it's not an x, right? I just know that I have the quotient rule, and then I need to have something times something over something times something, and then it's all going to be over something being squared. What was the something being squared? That's a t squared. Okay, and so that means my first thing is that t squared, and that means I'm going to multiply those two, and I'm going to put it all together nicely, right? So I have a negative, and I'm going to throw that in front, and then I have a cosecant of t and a cotangent of t, and golly, I do not like t's. All right, so then I'm going to have a minus sign, and I'm going to do these two multiplied together, and so I'm going to say that I have a 2t, and see, that t just looks so terrible. Cosecant. And ta-da! Now I'm thinking about all the simplifying that I could probably do, right? This piece right here is really a t to the fourth. And on top I have a t squared and I have a t, so I'm sure I could factor out a t. That's about it. It's really, there's not much left to be done here. So if you were doing multiple choices, I think the kind of answer you might see here is, since this is negative and this is negative, you might see a negative t out in front, and then a t cosecant t cotangent t minus plus a 2 cosecant t, and that should all be over a t to the fourth, but I can factor those out and end up with f prime of t is going to be a negative t cosecant t cotangent t plus 2 cosecant t, and that will be all over t cubed. So I've mentioned it before, the factoring, the simplifying, it just often doesn't get you very far in a calculus class. Feel free to leave your answer as you see it up there. For the next one, number 4, in that case, I'm not going to simplify this one. So you've seen that simplifying just doesn't look much more simple, so why not just leave it? And this is the product rule for me. And again, yeah, we've changed up the variable on you. We're going to use that theta. And remember that theta is an unknown that usually represents some sort of angle and often in some sort of radian measure. But you could just pretend it's an x, okay? So if I'm going to take the derivative of secant of theta, I will get secant theta and tangent theta, and if I take the derivative of the natural log of theta, then I will get 1 over theta, which is kind of crazy looking. All right, so g prime of theta will end up being as this times this and that times that. So I have a 1 over theta secant theta plus a natural log of theta and a secant of theta and a tangent of theta. And I have no idea what this function looks like, so if I were you, I would definitely throw it into Desmos. I bet it's pretty. For these last ones, it does say without a calculator to find that slope. I'm going to go ahead and find the derivative of this right now. Y prime is going to be -3, and the derivative of tangent is secant squared. So if I'm trying to figure out what's happening at x equals pi over 4, what I'll end up with is I'll say, okay, this derivative, when I throw in a pi over 4, will look like this. Ready? -3 times secant, and forgive me if I change my notation a little bit, just on a personal level. I always like to remind myself to find pi over 4, throw that into secant, and then square it. That's what that notation means, where the 2 is in the corner like that. So I just think to myself, well, what is secant of pi over 4? Let me think for a second. Secant is the same thing as 1 over cosine, right? So that we've just been exploring that. So this function, I want to know what cosine of pi over 4 is. And do you have that memorized? That one's actually pretty easy. Pi over 4 is that 45-degree angle. That's going to be the square root of 2 over 2. So when I say that I have 1 over cosine of x, the way that looks when I work it out is going to look like this. -3, and this is 1 over cosine of pi over 4. Have all that be squared. Okay, I'm going to keep working that out. Hold on. I want to give myself some room here. So I say then that my derivative is going to be -3, and this is, what is it? 1 over the square root of 2 over 2. And I've practiced this so many times. I want to make it look nice though. 1 divided by the square root of 2 over 2 looks like this. 1 times 2 over the square root of 2. What are we doing? We end up with a 2 over the square root of 2, but because of the rationalizing the denominator rule, I rationalize that, and I end up with a 2 over the square root of 2 over, well, the square root of 2 times the square root of 2, I end up with a 2, right? Because I get the square root of 4, and the square root of 4 is a 2. So many 2's. And these 2's cancel out, and I end up with square root of 2 as a final answer. So that's how I would go about doing this. I believe that if you did actually watch the video for that unit 0, you would maybe see another method. And hopefully, if you remember that, that is useful to you. I'm going to go ahead and finish this up with -3 times the square root of 2 as being my final answer. Oh, wait, sorry. And don't forget this whole thing was squared. Aha. Yeah. So I end up with -3 times the square root of 2 being squared ends up being -3 times 2, which is a -6. A lot of stamina required for that problem. So if you are trying to work that one out, be aware of the time. Don't let yourself play with a problem like this for too long. If you're not into having trig function values being memorized, this might be a good question to skip on the AP exam. Particularly when we get over here to pi over 3 and knowing that it's a negative pi over 3. Oomph. That's a rough one to have stuff be memorized for. So I say that this is really y prime equals -3. Secant, again, is squared, but this time I want to know what secant of negative pi over 3 is. And I'll mention that pi over 3 is supposed to be a half. And the shape of cosecant, the shape of cosine is such that I know that the negative pi over 3 will just be a negative, right, half. Positive 1/2. So both of them are, oof. Okay. So when I take a look then at this guy, I say I'm finding y prime of negative pi over 3, and this will end up being a -3, and secant squared, I want to find out what secant of negative pi over 3 will be, and I end up with that being squared. So working out that secant of pi over 3 is the same thing as 1 over cosine of pi over 3. What do you know about cosine of pi over 3? I'm hoping that you can remember that that guy's going to be a half, and that you remember, because of the nature of that cosine function, that the negative version, right, negative pi over 3, will still be a positive 1/2. Then, as long as you have those things memorized, we can work it out that this will be -3, and this is going to be what? 1 over 1/2, and square that. And by the way, again, I'll work this out. 1 divided by 1/2 is the same thing as 1 times 2 over 1, which ends up being just a 2. So this is really a -3 times 2 being squared. 2 squared is 4. 4 times -3 is a -12.